We are going to start our presentation here in just a couple minutes so we can allow folks to join. But while we are waiting for everybody to get logged in, we just wanted to check in and see where everyone is logging in from. So if you wouldn't mind dropping a note either in the chat function here on Zoom or in the comment section on LinkedIn, or if you're joining us from YouTube, please let us know. But would definitely like to know where you're joining us from today. My name's Melissa Russell, and I'm actually joining from just outside of Seattle, Washington. So if we can take a look and see where everyone else is. Stefan and Alex, where are you joining from?
San Francisco. It's actually lovely weather today here. A bit cloudy, but pretty warm outside.
Hi, everyone. I'm in San Francisco as well, right in the city, in the financial district. Like Stefan said, looks like a nice day today.
Well, we have got like the weather group here. We've got people joining us from Phoenix, from India, from Mexico. I'm really jealous of the person from Mexico because it's cold where I'm at. We've got people joining us from Poland and Russia and Italy and France.
And Spain.
Boston, Austria.
Japan, Greece.
Fantastic. Let's see. Well, we've definitely got every time zone covered here.
Yeah. Probably we missed a few countries, but I'm glad to see people from all over the world. Actually, yeah, like some of the people saw this behind the scenes, like the Zoom are in practice sessions. It turned out not to be a practice session and people can actually join. So we yet to figure out what's wrong with Zoom, but that was funny. So thanks for joining.
All right. Well, I think we are just about at the time, and we've definitely, everybody in Wisconsin and Minneapolis, I'm really sorry. It sounds really cold where you're at, but why don't we go ahead and get started? Again, my name is Melissa Russell. I am with WallArm, and I am going to be your hostess for today. Just a few housekeeping things to go over. We are recording this session, and I will be sending out a link to the recording most likely tomorrow morning. We've had a few questions about whether the slides will be downloadable, and the answer is yes, we will make a link available. And at this time, I would like to go ahead and introduce our speakers. Our first speaker is Stepan Ilyin. He is a co-founder of WallArm, and he will be joined by Alex Diaz, who is our VP of Security Solutions. So welcome to API Security for E-commerce, and gentlemen, take it away.
Yeah, thank you. Thank you, Melissa. Exciting topic. E-commerce is a hot space, and I'm glad all those guys are heavily reliant on API. So it's a lot to discuss here. I think it's good to start. The first thing I want to mention is that we try to make this webinar practical, right? Obviously we'll talk something about WallArm, about how we can help e-commerce and all online retailers, but we also will talk a lot about generally what are the issues, what's happening in the space, what kind of tools, including open source tools you can use to help yourselves in different situations. So we try to make it really practical, so it's not a vendor only webinar by any means. So thanks for joining, and I hope everybody will have some practical key takeaways and try something right after the webinar. So let's try to keep it this way. The agenda is very simple. First, let's talk about the API security challenges for the online retailers. Then we'll talk about what you can do with those challenges, especially in the multi-cloud environments, cloud-native environments, basically when you have a lot of APIs all over the place. And let's talk a bit about what's wrong with the current security solutions, where they can help, what are the lags they have, and where do you think you need to fill those gaps. So this is the plan for today. This part I want to keep very short. Obviously, all of us know e-commerce has a lot of challenges, in terms of the fraud, in terms of the security, and the news about the data breaches all over the place. So everybody know that. So we probably will skip it and jump right into the technical challenges. Hopefully that's okay. But if you want to talk more about basically what are the challenges on the API security space, that just let us know, because we have a dedicated webinar on that topic where we can basically talk high level of what's wrong with the API and product security in general, so that we can provide you some more details on that. Here, I want to start with the challenge number one. So we all love this new tech, fancy protocols, new CMSs, new platforms, new connectors, new RPAs and everything else. So the challenge is very simple. Like there's so many new cutting edge stuff everywhere that it's really, really hard for the product security teams to deal with this. It just go to any product security director nowadays and ask like, do you know like all the technology stack that you are currently using? And the answer would be probably, I'm not sure, or he would say, kind of. Like nobody will say yes, because like everything is changing so fast. Like our engineering teams are trying to move fast, like and do it faster and faster. And like as a security team, you need to keep up. And yesterday it was all about the rest. And today, like we talk a lot with the GraphQL, our gRPC use cases, WebSockets, which is with us for quite a while, but it really gets adoption right now. So it is getting different tasks. It's just new technology stack, new protocols, and as a result of it, like new threats, because something that was very dangerous for general applications is not that relevant anymore for APIs. Our gRPC brings its new challenges. GraphQL has some new threats as well. So like while keeping while dealing with this new tech stack, you need to know like what is happening, and this is just a fact. Like there are so many technology out there that it's really hard to protect all those things. And one of the important things to mention is that even though you probably have some of the security tooling in place, right? Like you have web application firewall, for instance, but the question would be like, can this WAF really protect your gRPC APIs? And I'm not even talking about the gRPC APIs. Like, are you sure that it actually can analyze traffic for your REST APIs and do this inspection for all of the API calls? I wouldn't be that sure, by the way, about that. So always keep in mind that if you're adopting new tech stack, if your engineering teams get more and more fancy stuff, you need to think about like what are the new threat vectors, and if your security tooling that you have in place are really enough to protect all those things. And some of the interesting facts here, like 83% of all the web traffic are API calls. So this is the data from Akamai. Those guys have a lot of traffic, right? So 83% of the web traffic are API calls now. So like basically if your solution is not really capable to analyze traffic for APIs, like legacy WAFs, is basically a blind spot for them. And just keep that in mind. What Gartner is saying is that the APIs will be the #1 attack vector this year. So are they too optimistic or not? So like, let's take a look what will happen in 2022. But obviously this is a big attack vector right now, and we all will need to deal with this. This is something that we will talk later today, but most of the WAFs are not really ready to protect your APIs against API-specific threats. Some of you guys rely on the API gateways to protect against some of the stuff, but it's again not really enough. And the interesting question here is that everybody understands API security from different perspective. Like, and if I ask you right now, like, what is the API security? A lot of you will give me different answers. Like some of you will say something about authentication, or some of you will mention authorization, some of you will mention some of the threat prevention. And like the good way to look at it is maybe to go through the API OWASP Top 10 thing and to go through all of the threats and see like what is there. So what we tried is basically add this color coding to this API OWASP Top 10 so that we all speak the same language. And like, if we talk about the broken user authentication, we obviously talk about authentication. If we talk about the injection, for instance, like we're talking about threat prevention. So it will just keep us to use the same vocabulary. So hopefully this will be helpful. One of the things is something to deal with is API gateway, right? Because like if you have APIs, obviously you probably have an API gateway, and in many cases people are saying, hey, yeah, we are thinking actually about API security. We do have stuff at our API gateway and we do a lot of things there, which is true. It's just like not always API gateway is the solution that can help you against everything. And that's why I included this slide here, basically to give us all understanding of what API gateways typically can do, like API gateways, including Kong or Tyke or APG, for instance. and what the specifically API security solutions, or sometimes next-gen WAFs as well, can provide on top of it. So for the API gateway, we typically talk about authentication. We talk about the access control. We talk about the encryption, including TLS. We talk about cores like cross-origin resource sharing. And obviously, rate limiting is something like one of the most important things you need to do, like the API gateway, including caching. So those things are perfectly fine to do on the API gateway level, and you should do this there. So like, if you don't have API gateway at the moment and you have a lot of APIs, like obviously you need to get one. Where you need help is actually protecting against different kind of OWASP Top 10, API OWASP Top 10 things like injections. You need to have protections to block malicious sources like Tor, different kind of proxies and everything else. You need to have something that will protect your APIs against abuse and misuse. You would need to deal with a different kind of denial of service attacks. You need to know like what do you need to protect basically to do the API discovery thing, and more. So like those things are not covered by any API gateway. So like you would need something on top of it to provide it. In some cases, you can use some open source tools. We'll talk about that. But in some cases, you probably will need to go to some vendors. One of the things that I'm excited to mention here actually is our open source API firewall. So like it used to be free. So like literally last week we decided to go open source. So like now like it's fully available. Like you can download to use as a Docker container. It's available at Docker Hub, and it's has like 1 billion pull requests there as well, which is a great thing for us. It's actually a very interesting concept where we just do the API schema validation. So you basically upload the schema. Let's say it's a Swagger about your API. And what this API firewall can do, working as a reverse proxy, it can match every incoming request against the schema and make a decision if this request is malicious or not, like if it matches the schema or not. And this is the way it works. So obviously it will allow calls that match a predefined API specification, and it will basically reject everything else. So a very easy concept. So this is a key to understand how it works. And as I've said, like it's a Docker container, so you can deploy it anywhere you want. It's totally free. If anyone from the vendors will come to you and say, hey, we are providing API security. And by API security, they will basically say, hey, it's a schema validation. Just mention to them, hey, this is the open source thing. You can just like, we can take it and use free of charge, because we believe that this basic thing should be available for everyone. Like there's no need to charge money for that. Like it's basic, fundamental thing that you just need to start with. Just an example of how it works. So you run it as a Docker container. There is a valid request where like name is supposed to have only letters. And like obviously in this case, the request will go through to the API. If you will include numbers into the name field, like the API firewall will see, okay, these are the numbers, they're not supposed to be in this field, and the request will be blocked. So like it is as easy as it is. Next challenge. And this is especially true. I bet like this is one of the #1 things for the e-commerce space is the account takeover, basically bots, right? And we need to deal with them in a variety of situations like scrapping, API abuse, account takeover, credential stuffing is another name for account takeover. So all those things are really annoying, so to say. And I think this is the #1 thing in the e-commerce space. Like we all need to deal with it. So can you do anything by yourself, right? Without going to the vendors, without asking for, without buying any products? The answer is yes. So you can do a lot of like we call it do it yourself stuff. So you can do a lot of things that can help you to protect against like at least basic bots. So you can block some Tor proxies, non-bots. There are some TI feeds that you can get free of charge. You can block traffic from the data centers because in many cases, your users wouldn't come from the data centers, right? They wouldn't come from the AWS or GCP. So that would be a good sign that it's probably a bot. You can introduce capture. Like in some cases, you can use it free of charge. And obviously there is reCAPTCHA, which is a paid one. but there's also like free captures as well, so that you can use it. You can fingerprint users. This is more important, I think, for the fraud prevention, but as a matter of fact, you also have some free open source tools like Fingerprint.js would be a good starting point. This is a library that you can use free of charge. And obviously, if you don't want to do everything by yourself, you can try commercial products like API security and bot management. So talk to us, for instance, but in many cases, if you're dealing with a complicated account takeover attacks, this is hard to deal with just by yourself. Like it will take a lot of efforts, time of your engineering team, is just like way more effective and to use some commercial products. One of the things that I would consider blocking, it's some geographies, or if you work only in Spain, there is obviously a good idea that you can allow the traffic only from Spain, for instance, or you can block all the Tor nodes. You have all the IP addresses of them. Some of the providers sell feeds with the proxies, anonymizers, and everything else. Like one of them is MaxMine, but it's not the only one. It is paid, but it's not crazy expensive, so like everybody can buy it. And think also about the different kind of honeypots and databases with the IP addresses that we were known to be involved in the malicious activities. So some of them can be pretty good in your own do-yourself kind of measures. Speaking of the providers, by the way, like all of the largest one, like GCP, AWS, Azure, they provide the feed. So you basically can get the full subnets of those providers, and you can block them if you want. Switching the gears to the next challenge. Challenge number 3, how to keep up with the high velocity of development. This is incredibly hard for years. Now with the APIs, it's even more complicated because some of the tooling that you used to use for testing your applications is not really suitable to test your APIs. That's just like a fact, right? Because APIs are so different. And they are, in many cases, you just can't do manual testing. Like, as a matter of fact, you can't do manual testing. Like, you can do that, but it wouldn't be the continuous development, right? So you need to think like what you can include into your development pipeline, into your CI/CD pipeline, to test your APIs automatically. And yes, the solutions are kind of the same, right? You can use SAST, like static analysis. You can use DAST, or dynamic analysis. You can use composition analysis, like SPA kind of thing. All those things you can include, but just make sure that those tooling is suitable and is a good fit for testing your APIs, because in many cases they are not, unfortunately. And to make it more practical, I included a few things here that actually can be used to test your APIs, like Zap. There's a great project from Microsoft Research Team, which is called Wrestler, where you can basically upload your schema, and Wrestler will do this testing, and it's really a good starting point to start with this. There are a few other things here. One thing that I want to highlight is the project which we call GoTestWeb. It's another open source project from Wallen team, and don't be fooled by the WAF of the name. It's not about WAF, actually. It's all about testing the security of your existing security tooling. I will talk a little bit more about them a bit later. Challenge number 4, false positives and false negatives. So where false positives kill your revenue. So if you block any customers by mistake, that's a terrible, terrible kind of thing you can do, because like nobody wants to lose customers. And if security tooling blocks customers, there's probably no place for this tooling in the company. So like you know this better. But also what we see, and this is a big mistake a lot of companies are doing, they think a lot about the false positives, but they really ignore the false negatives kind of equation. And I would encourage you to think about both of them, because yes, you don't want to block customers and you want to have the false positive rate near 0. But you also want to make sure, like you need to make sure that the security solution that you're making a part of your infrastructure, or the security solution that you will be relying on building your API security strategy, is actually capable of identifying different kind of attacks. And a good way to check it is exactly with this project I just mentioned, Go Test Web. So it's basically an open source tool that will send a bunch of requests validating different kind of attacks, trying different encodings, trying different protocols, trying different use cases. And as a result of it, you will get this report, which would say how your apps and APIs with your existing security tooling are really protected against different kind of threats. And that's a cool thing to do. Like I encourage you to try it right away, because in many cases you would be surprised, like why this solution I'm having for years, where the vendor was claiming to provide this protection for REST APIs, in fact doesn't provide the proper protection for them. It's you'll be surprised because you will get this full report of what was detected and was not, and it was developed by Walrus, so we're obviously biased. But I think since it's an open source tool, it's fully open. You can just check for yourself and see that the behind every point here, there is a proof. There is a proof that something is wrong and you need to care about this. Challenge number 5, how to find the tooling and solutions that can actually work in your modern environment. While talking with e-commerce companies and online retailers, and we do a lot of it actually, we see that multi-cloud is a thing. So more and more e-commerce companies are moving from using only one cloud provider or even their own data centers to using a couple of them, like GCP in Azure, AWS, like in some cases, it's ignored, especially by the largest e-commerce, since Amazon is a huge e-commerce company as well. But Amazon is obviously a big player, and there we see Amazon, GCP, Azure, Alibaba, all of those clouds. And some of the situations that we observed during the last 12 months are the request to find solution that can work everywhere. If you use AWS and you kind of having a web, for instance, you can use AWS web. But what would happen if you will move to using AWS and GCP altogether? You don't want to use different webs. You don't want to manage all of those things. There's also no API security as a part of those solutions. So ideally, you need to find a product or products or tooling, like open source tooling, that can be a good fit for everything. And if you're moving to Kubernetes, which is most likely, just try to think something that can also work on top of the Kubernetes thing. And this is just like a very important thing. The situation that you don't want to find yourself is that when you find something that is a good fit for one cloud, and then next year, management decided, hey, we go multi-cloud strategy, or we just switching the cloud provider, and you need to start everything from scratch because like the whole thing that you implemented before was not cloud agnostic, and you need to do everything from scratch. Like this is not fun. Just don't do that. Challenge number 6, how are actually to include everything that you're building around the API security and typically about product security into your existing workflow and tool chain. And one of the mistakes we see all the time is that people introduce more dashboards, more reports, and everything else, while they actually in many cases should think about how to make the unified workflow, especially by working security with development, our DevOps, with the SOC teams and everything else. And the only way for that is actually to use different kind of integrations and make sure that you build a unified workflow that everybody understands and everybody is using the very same tooling. So it is possible to use that. And just think about a few things. Integrations, our infrastructure as a code, are probably the most important thing. So you need to manage security in the very same way you manage everything else. In this case, DevOps people will be your friends. If you would have all the integration with the DevOps tooling, it's more likely that you will be on the same page. And in many cases, you can do a lot of stuff even using the open source tool. So, and I encourage to take a look at the open source tools. In many cases, this is a low-hanging fruit. You can start with it, and you can identify gaps, and then maybe you can go and try different commercial tooling. But one of the things, for instance, that we recommend if you want to get visibility in the malicious traffic, for instance, is to use a combination of a couple tools like our ingress controller. If you're using ingress, or you can use the open source Moz security right on the ingress controller. You can get events with the Fluentd, and then pull all those events into the Elasticsearch and get a great visibility with the Kibana. And you can even set up different kind of alerts, like and get alerts if something is off using the Elast alert. This is an open source project from Yelp. So having all those pieces will allow you to get like good visibility and good integrations with different pieces. Yes, you would need to set all those things up. You need to manage, but this is free. This is what everybody can just take and try use it. I wouldn't go into the details here, but I will share the slides. But it's a pretty straightforward way how we can plug all those things together, because all those things are already implemented to work as a one unified thing. So as a result of it, you will have dashboards, or you will set up different kind of alerts, like I want to know when there is a spike of the attacks against this endpoint, for instance. That wouldn't be that granular, unfortunately. So you wouldn't be able to create the rule specifically for the different kind of parameters for this endpoint, for instance. But you can get something, and in many cases that would be enough for you to start with. But you also have this flexibility to configure and get everything you want to get out of this thing. And obviously you can set up the alerts to whatever products you have. It can be something related to the DevOps, like PagerDuty and OpsGenie, or you can just send a message in Slack, and a lot of other things as well. Challenge number 7. This is interesting. This is a challenge and / observation from what we hear more and more. And this is also the observation that I really like. During the last, I would say 18 months, we see more and more companies in the e-commerce space that actually think about protecting APIs that are exposed, like apps, APIs, or all the other web assets. But also they started to think about the internal assets, like microservices, internal apps. I would say that this was probably associated with the COVID as well, when we all of a sudden require the access to some of the tooling that was for years just internal. Long story short, zero trust is here, and we, in many cases, build our security programs thinking that internal assets are same as your perimeter. So like it's really hard to understand like what is your network perimeter anymore. So that's why a lot of companies started to incorporate security features and tooling for microservices that are not even exposed. And while using the tooling, I would say this is a challenge. You need to think about something that would be a good fit not only for the exposed assets, but for everything that you have internally. And this is where I know that e-commerce and CDNs are always come together, right? Like there is no e-commerce that wouldn't use CDN. Like we all need this network where we can host images and everything else to get and gain great customer experience. And it's very lucrative to use, for instance, WAF at the edge, because this is where you can do the caching, and this is where you also can do this traffic analysis. Unfortunately, this is something that you can't use for your internal assets, right? And yes, you can still use CDN kind of WAF, and then you can add something internally, but that would be different tooling. It wouldn't be unified. So there are a whole set of new challenges there. So I would encourage you to think about solutions that can actually cloud native, that can be deployed in Kubernetes, they can be deployed with a service mesh, because this is something that you probably will adopt in the coming months, or something that could be deployed as a sidecar. A lot of companies we see now are getting more and more familiar with the Envoy proxy and replacing something like Nginx in their architecture. So like ideally you need to find something that can work there. So think of it, because this is the new challenge. You need to protect internal assets. You need to analyze east-west traffic, and this is something that you probably haven't done before. Speaking of Alarm, we'll talk more about the integrations and deployment, but one of the two most popular ways of deployment is basically to deploy as an ingress controller, or to be deployed as a sidecar for application pod in the Kubernetes. So like those are two very important questions. Challenge number 8 this is a big one, and this is somewhere where probably talk less. Compliance is not fun, but like we have more and more of it, all right? So it's PCI DSS, GDPR, California Privacy Act, and everything else. So there's so many things to keep in mind now, but this is something that you just can't ignore. The good thing is for compliance, it's easier to get a budget. Like a company can't operate if you're not compliant, right? This is something to keep in mind and to work hard. This is a topic on itself. I wouldn't go into this, but APIs are the reason for the data breaches. And obviously, if you have a data breach or security issue in API that leads to the data breach, it would be a violation of compliance, and that's why I included it here. This is a big thing to think about. Like API security by itself it is not mentioned in PCI DSS. It is not mentioned in any other compliance, like where you probably have it, like SOC 2, for instance. But this is so important to think about those things and just not ignore. I'm actually pretty sure that API security and like basically product security would be a part of many standards pretty soon, because there is no way how we can just ignore this anytime longer. Last thing I promise here, before we go into some of the demos and everything else, is the discovery piece. I mean, the industry was talking about attack surface management for a while, right? It's not a fancy term anymore. What is new and unusual actually is API discovery and API inventory. I think those things are very important to mention while talking about the API security overall, especially for the e-commerce. We're dealing with the companies with hundreds and thousands of APIs. In many cases, we ask a question: do you know how many APIs you have? We have an answer, around 100. Then we do the API discovery. And in many cases, the actual number is 170, 150, 180. It's like way more. And we're asking like, hey, why is there such difference? Like companies just, like in many cases, don't know what is really exposed. What are the versions of APIs exposed? Like why v3 version of the checkout is still exposed if the up-to-date version is actually v5. And after some investigation, it turns out that v3 was left there because of some compatibility issue, and then like somebody forgot about that. And we see this all the time. So you just need to have something for the API security piece, and there is some open source things. Once again, like new projects like API Clarity by Cisco, which only works in the Kubernetes environments. But if you want to have this robust API discovery that will work across all your environment in any cloud, you would probably need to go to a dedicated vendor for that. I want to talk a bit about Alarm, obviously, because all those challenges, we see them, and they're like for 5 years, we actually been working on how to make sure that we can protect our customers and help them to protect APIs. We help them to analyze a lot of API calls, like billions and billions every day. And the customers love us. Like we are #1 security solution in SHIP2, and we're the only leader in the grid there. So like it's always pleasant to have all those things. One of the things that everybody will inevitably ask when we start talking about the product is how it's actually deployed. So I want to start and maybe spend 30 seconds on this. We use so-called hybrid approach when all the traffic is analyzed locally. So we don't want to have copy of your traffic, mirror of your traffic, or anything else. So the traffic and your customer data is staying in your infrastructure and analyzed with the so-called Waller nodes. They are deployed as a reverse proxy. And another question that we would inevitably have is, hey, it's reverse proxy, what about latency? And we just invested a lot of time to make it almost zero latency. So you can just deploy it in any infrastructure and get very fast performance with almost near zero latency. So we have e-commerce companies all over the place, and all of them use this in a blocking mode, being deployed in line with a variety of deployment options. So we have our whatever infrastructure, whatever cloud, whatever multi-cloud architecture you have, it can be deployed anywhere. So it can be deployed as a ingress controller or a sidecar in your Kubernetes environment. If you just have a software load balancer like Nginx or Envoy, we can just plug in the module there and you don't need to deploy anything else. If you're using API gateway like Tyke or Kong or anything else, we can plug a module there, which is very easy. If you want to start very quick, there is a marketplace image for almost any cloud, or there is just a Docker container, which you can deploy it and try it as a reverse proxy. One of the new deployment options is basically CDN-based option. Like we do this with a partnership with Lumen. It's one of the largest CDN in the US. So in this case, you don't need to deploy anything in your infrastructure at all. And we invested a lot of time actually into API-specific features. Waller is the product that can protect everything. It can be microservices, it can be applications, it can be just website. But where we actually was maniacally focused are the APIs. SOAP, REST, WebSockets, gRPC. So over the years, we added more and more features. And what we provide now is a few things: discover, protect, respond, and test. So discover is basically all about the API discovery. How, based on your traffic, without seeing this traffic, by the way, give you the full specs of what APIs you have, what are the methods, what are the parameters, what are the changes there, and everything else. So like the full attack surface, Alex will show in the demo, in terms of the APIs, and also exposed assets, you will get it as a result of using Waller. Protection piece is probably the most important part. This is what we call API threat prevention. With near zero latency, we will analyze your traffic and in real time can identify those requests, those API calls that can be malicious, and just block them before they hit the API backends. All the visibility you need, you get. We call it response piece because we give you full details about what is happening, what are the malicious traffic, what are the chains of the attacks, what are the attackers are doing there. But the important thing is actually that you also can automate the response, so we can validate the attacks with what we call active threat verifications and give you some insights of what of those attacks were really dangerous. And I talked before about necessity to integrate into the unified workflows in the company. So this is what you can do with the integrations with pretty much anything like SIEMs, SOARs, messengers, like any other DevOps tools. So it's just here. And testing is also very important, like how to test those attacks, how to create tests based on your actual traffic and the attacks we see in the wild. So this is a part of the platform. We believe that this is discover, protect, respond, and test is the real end-to-end approach, and encourage you all to try this out. And with that, I want to pass the baton here to Alex so that he can talk more about that.
Perfect, Stefan. Great content. I was answering a couple of questions. I'll let you continue helping people to answer the questions. But you mentioned that slide and the two slides you have, and then I switched to my screen, Stefan.
Yeah, absolutely.
So one of the things that it's important to recognize is the changes in protocols and applications, like how people delivering their own applications. When you think about WAF and legacy applications, they used to run only on HTTP, so the scanning and the inspection of the requests were only done at that level. As you move into Kubernetes and modern environments, all the requests happens most of the time via APIs. And these APIs have evolved in new protocols like GraphQL, sponsored by Facebook, gRPC by, sponsored by Google. You have new protocols and new applications that using more advanced concepts and protocols that they need to be addressed and protected. As you can see, WebSockets bidirectional communication, the same for gRPC, and streaming over HTTP2. So those, in order to protect those protocols, you need to have parsers and understand them. So that's a big difference from the old technology that now that needs to be addressed and protected. Stefan, can you click on the next one, please? That said, the way to do it is with a deep inspection in every request. So there's a raw request coming into the system. In this case, a Waller node acting as a proxy. And the first effort that has to be done is to understand the protocol. Is it gRPC? Is it GraphQL? Is it a WebSocket? Then parse the request into the schema. In this example, it's a REST request. As you know, that there is a specific schema. There is a JSON format, and those fields, they need to be inspected for a malicious payload. Is it a SQL injection, cross-site scripting? So now, what about if that specific field has a base64 encoded, and the attack is hidden into that encoding? So Waller is able to parse and decode that attack directly from the request in real time and be able to identify that request. Those are my 2 slides. There's one more I want to show you. I want to share my screen and before we move into the demo. So a little bit what Stefan described. So you have the user request coming into the Waller nodes. Now, these Waller nodes could be pretty much anywhere. Could be in a Kubernetes ingress, could be a Nginx in a EC2 instance, and a Docker container, a physical machine. The idea here is acting as a proxy in the traffic line, and before going into your application, will cross Waller. There, the requests are being inspected by Waller, and any there's a criteria is going to be defined that all these requests, that malicious requests, will make it to the backend, and they're based on the intelligence using statistical methods, algorithms, and part of AI. They're going to take those requests and they're going to reconfigure a specific rule set to your application that is going to get pushed back from the intelligent backend back to your Waller nodes. This is a continuous process. The more data, the smarter the system gets, and the more protection will get into the system. When that happens, now let's move into our demo. You will see in the events page how these requests are being analyzed. You have all the attacks coming into the system. These attacks could be of this type, could be a SQL injection, cross-site scripting, remote code execution. One example could be log4j that could be there, and also resource over limit. You have a request that is taking more than 50 seconds using and preventing other users from consuming your services. If I expand one of them, I'll show you a little bit of the data that and the inspection that Waller is doing. He's able to see the malicious payload, the source IP, and if you're in blocking mode, this specific attack never made it to the application. So your application that you need to process this transaction was a malicious, wasn't a normal request trying to consume the service. It was an attack. Also, you can see the header was inspected, the URI, and also you can see the attack, in this case, in the body, how was detected. Now, if this one was also encoded, will be decoded on the fly and detected by Waller and stop it if this was an attack. You can see all the attacks over time. Something I want to also to mention, and that Stefan mentioned previously, is the discovery of your APIs. Most of the technologies out there will require you to upload the schema. Waller doesn't require that. Basically, the schema is built from natural user traffic, from requests going through your APIs. So from those requests coming into your APIs, automatically without doing any manual configuration, Waller is able to detect all the requests in a Swagger format. Probably you are familiar with working with APIs. You're able to see, for example, the post request. Not only that, you can see where these values were used in your APIs. Is a JSON, it's part of a JSON body, is in the header. For a GET request, you will see also the request has been probably as part of the query. So all this actually showing the real usage of your application and how your services are being consumed. Now, how can you use this information? One of the questions in the chat is how can you prevent if there is some deprecated endpoints that it shouldn't be here anymore? How can you detect shadow APIs? Well, this is the real traffic and the real usage of your APIs. The way you can do it is you can actually download the schema that has been built directly from the wire, and you can download it, and it's becoming a JSON format that you're able to open it and upload into a JSON editor and compare it with the one you have in your CI/CD pipeline or the released specification you have. Other things I like to show you as part of the product is a scanner, vulnerability scanner. For that, I'll go here, and as you think, let me take a hacker's hat for a moment. Every time someone is trying to attack you, the first thing he's going to do is recon, trying to find all those endpoints you have available there, and they're public, to see if they're able to create or be used as an attack vector. What Alarm is going to do, based on once you specify a certain range of networks or domain names, is going to discover all your assets. In this case, your main domain name, all the subdomains, using all the DNS technology and available there, DNS records, SFT records, SSL certificates, and be able to map and find all your resources. Could be endpoints that you're not using anymore, an opportunity for you to address them and probably remove them. Also is going to discover the IPs and ports. So what Alarm is going to do with that information is to, first of all, run a CVEs and CWEs database against those endpoints. I may discover application-specific vulnerabilities. PHP could be operating system, OpenSSL libraries, etc. That could be something that you will need to address. We'll show you the CVS number and actually how this can be reproduced with either a command. In this case was an nmap. If you do an upgrade, was a version, listing a CVE, and you update this, and this another one discovered, this a continuous process, so it will be discovered again. And you will see all this as a vulnerability scanning when it actually is being used with CVEs and CWEs. Another interesting method that Alarm is going to use to stop an attack is using the initial attack from the attacker or the hacker. You will use the same endpoint that has been used. So this is the original attack. You can see here is the endpoint example.com login, and the attack clearly you can see it as a SQL injection. Alarm is going to reuse that initial attack and add variations to the attack to enhance it and try to see if there's a vulnerability in your system. This is exactly the same as an attacker will do. It will try once and then try to break it by adding variations of the attack. So in this case, Alarm is using the attacker intelligence by using the first attack and be able to see if there's a vulnerability by adding those variations and different type of payloads. One other thing I want to touch here is, I talk about, is passive detection. It's another system used by Alarm that is looking at the responses back to the system. For example, you have a SQL error that is exposing your database structure that you don't want to share it to the end user. That API call or that specific response should make it available to the client. At that point, that type of information belongs to your server logs and you don't want to expose it. The other thing is, for example, a password database. So here will be listed as a passive detection. Another thing I like to show you that you can use is triggers. Triggers allows you to integrate the system with all the event discover and all the security information and be able to trigger, for example, an action. People were asking also about how we can rate limit to a certain extent connections to a specific endpoint. So in this case, if you have 30 requests over the last 30 seconds, you can have, for example, you have a login page that you want to add. So you have 30 requests per second over the last 30 seconds. You go beyond that, then you want to do, for example, an action to it. You can mark it as a brute force, and also you can add it as a blacklist as a reaction, for example. for 4 hours or at the time you specify here. This will allow to just to kind of do a damage control and slow down the user who's trying to break and into the login page of the login API. The other use case for this is if you want to, that's one of the examples that Stefan mentioned in the calls, that the hits go over 1,000 per day. At that point, what you can do is add a reaction to that. You can notify via email, Slack notification, or add the event to Splunk, for example, or any other SIEM. So let's go. One last thing here is the rules. Walorm has been designed to be self-maintained. So we want the security intelligence of Walorm to take care of the rules. So in the best case scenario, the rule set, as you probably know from legacy API security or WAF, is you have to maintain a versioning, and the rules will appear like in a firewall. We have a numbered rules. With Walorm, these rules are automatically created based on the profile of the application. There are cases like when you want to apply a specific rule. Let's say you're onboarding a new application, and you want to add a specific rule for this, and add this rule into monitoring mode. But while the system is learning, and you can add this filtration mode in this case as monitoring. Once that 7 days has passed, the alarming has learned about the security model, then at that point you can set it back to a blocking. The other thing is if you want to filter specific data because you have a PCI compliance that need to abide for. So at that point you can also mask certain fields to be able to hide them from the backend. Let's finish with the dashboard. Here is the main dashboard for Walorm. In this graph, you see at the bottom, the blue lines, you will see all the requests coming in, good and bad. In orange, you will see all the attacks coming into the system. In red, the incidents that probably went through the system if you are not blocking more vulnerabilities detected by the scanner, CVEs, or active threat verification. Also, you were able to organize and see your applications organized by API, or you can organize it as a dev, staging, and production. You can see the incidents and trends happening in the system. Top attacks by type and attack vector, RC, path traversal, in this case being on the top. You can also see the sources. You can see the countries where these attacks has been generated. And if the information is available, you will see also the data centers. So that's a short demo, but if you want to see more, feel free to reach out and we can go more into detail. Happy to open this.
Thank you so much. I think that was a great demo. We have we have a few minutes, and I think it's perfect to maybe answer a few questions. So, yep. Hey all.
We have one that we need to answer right away because I'm getting it on several places. For everyone who has been asking about the slides being available for download, if you are on the Zoom call, please realize we will definitely be emailing you directly. For those of you on our LinkedIn channel, if you could either send me an email at mrussell@walorm.com or request@walorm.com, I can make sure that we get those out to you. And then at this point, if anyone on the channels, you can add in questions either into the Q&A chat, or we are also monitoring the comments field on LinkedIn. So it looks like we have a couple questions that have already come in from the Zoom side. Stefan, did you want to take those over?
I think so. Yeah, there was a question about the authentication and authorization. That's
the first one I'm seeing in the Q&A is, how is this different from DOS, D-A-S-T?
Yeah, so DST is a great question. So DST, just for the context for everyone, is Dynamic Application Security Testing Solution. So we do have some components that use this DAST approach, Dynamic Application Security Testing. For instance, let me show you very quickly. When we detect the attack, we can validate it and say if the attack is really dangerous or not. So like this is what we call active threat verification. And the way it works is by using dest. You can see my Warm console, right? So for instance, this one, there's a GraphQL attack. What we can do when we detect this attack, we can block it. But what's next? We can create a task for our dest scanner by saying, hey, we actually identify the attack at this domain, at this endpoint, in this parameter, and this was a SQL injection attack. So in this case, there would be a specific task created for the our own dest that will go and check this particular endpoint and give an answer if it's really vulnerable to SQL injection or not. So as you can see in this example, it is not vulnerable. So that's why we put this green check mark here. And as you can see, like all the time, we try to put like green check mark. A red one means that we couldn't validate it. And in many cases, hopefully, you wouldn't get any vulnerabilities detected in such a way. However, in some cases, there might be vulnerabilities that would be identified. And in this case, we will say, hey, this is a very serious situation because we believe this is a security incident. We actually check the vulnerability, or check the attack with the dest, and we identify that there is a vulnerability security issue. And you can open the details of it and understand like what do we mean by this. So this is one of the dest component. And another one is we have a special dedicated piece which we call framework replication security testing. So this is one that can be incorporated into your CI/CD pipeline to automate security testing, and it's based on dest approach as well.
Yeah, let me answer the other questions that are coming. So there is one that says on the vulnerability scan, do you also check for bad inputs like various attacks patterns we saw in log4shell? Yes, definitely we do that. So we can identify using the active threat verification on the scanner any vulnerability related to that.
Another question: if API built without open API spec, can API discovery discover API endpoints correctly? Yeah. So this is the beauty of the product, actually. So we wouldn't ask you API specs anywhere. So it will work right away, right after you deploy Walarm, and there is some traffic. Let's say it's REST and GraphQL traffic. We can identify like all types of the attacks without asking you for any specs. This is the beauty of it. And as a matter of fact, like we will create the specs in the API discovery page just based on the traffic, just based on your actual usage, like based on how your users interact with APIs, which is a big difference from a lot of other vendors, especially web vendors that are trying to keep up on the API security space, and they only provide this API schema validation as the option for protection. So like this is a big difference of Walarm against everything else.
So there's one more that says we need to have access to decrypted traffic. Yeah, that's correct. We don't do any AI or analysis, but the good news is you can think about it as an Envoy or Nginx. So you can decrypt, analyze, and encrypt again back to the endpoint. As you can see, as we demonstrated in the demo, it requires to go over the analysis on the full request. So for that, is required to be decrypted.
We have another question that came in from LinkedIn. There was just a question in general: is how do you handle the false positives and false negatives?
Oh, this is where we can talk a lot, actually. But let me show you this. We have a lot of research done specifically on this one topic, because one of the mission we have is to make sure that the products we build can be used in the blocking mode. So like nobody wants to have a security product like this one that would be only used in the monitoring mode. We actually want to mitigate the attacks. That's why we sit in the traffic. That's why we're sitting in line. That's why we can block it. And we put a lot of efforts into developing different attack detection techniques. So one of them we actually open sourced. You can try, I'll show you here very quickly. So we call it lib detection. So the way it works, it doesn't use signatures. So like we hate regular expressions. You can still use them if you want to create a rule, like static rule with a regular expression. Well, you can do that. However, most of the attack detection techniques of Walarm, they don't use any signatures, any regular expressions. Lib detection is one of them. So this is basically the attack detection that is purely based on the grammar analysis. So we describe the grammar, let's say SQL injections, and Now, we don't need any samples at all to identify SQL injection, so it's super accurate. And there is a couple of other things. So if you're interested, like happy to talk on that and share some white papers of how we can do that. But we just invested a lot of time and implemented a lot of our algorithms. And obviously having more and more data about the attacks just help us to be more and more accurate every day.
There one more. How do we detect insecure data access? Well, I can say something about that. So we detect the malicious payload. So if there's a malicious payload that has as a target to exploit that data access, will be discovered, and it could be in any of the could be a SQL injection, for example. Cross-site scripting will be detected by Walrm in that respect.
Yeah, on the vulnerability scan, do you also check for bad inputs like the various attack patterns we saw in Log4Shell? Yeah, absolutely. Absolutely. Yeah. So
to deploy on Kong, do you use a plugin? Yes, we have an integration with Kong. Send us your version, and we'll happy to verify we have that integration with that specific version.
Could you please share all GitHub and architecture information after presentation? Yes, we would include everything. So like I think I mentioned our at least leak detection, our GoTest WAF, our API firewall. Those are things that are open source, and I've mentioned them during the presentation. So we'll include all the links.
We have another one that came in from LinkedIn. Can we block legacy API or grandfathered endpoints?
Absolutely, yeah. So like, we just need to understand like what would be the best way to deploy there. But one of the things we mentioned multiple times, but I would mention another one, is that we are platform agnostic. So we just need to see the traffic. You need to find a option that would be a good fit for your architecture, somewhere in front of this legacy APIs. If the Walrm node can analyze and see the traffic, it absolutely can protect like legacy apps or APIs anywhere. It's a very usual thing for some of the e-commerce companies, by the way, having this new very fancy APIs for online shops and mobile apps, but also there's a legacy something in their infrastructure which the customer is also protecting.
There's one question about how we get the Zoom recording. Elisa, maybe you can.
Yep. We are definitely going to be sharing out the Zoom link. I'll be sending out a follow-up email, but we also have it available on our YouTube channel as well. And let's see.
Okay.
We had a couple more questions if we wanted to go over the hour. There's still 2 more that came in from LinkedIn.
Yeah, let's maybe spend a few more minutes if there are questions like that. Yeah.
It was a follow-up to the blocking legacy API or grandfathered endpoints. Is how about integration with Gloo Edge, GLOO Edge?
I think we had someone recently, and the sales engineering team figure out how to do that. I'm happy to talk into the details, but I don't have them handy.
Yeah,
I think the architecture of Walrm is that we made it really possible to include and incorporate into any other tech stack. So that's why we have a lot of partnership with the CDNs like Lumen, for instance, where our technologies are basically incorporated there. So in many cases, even if we don't have, like it's a very new something, we definitely can explore and take a look if there is a way of our deployment.
And the way to go with that, send us an email to solutions@walrm.com.
Yeah. I think there's so many messages in the chat here and some questions. So probably skipped something, but thank you very much, all. So let me share the email, request@walrm.com. If there are any questions that we missed, it's not intentional, we just missed them, but happy to talk on them. Just shoot us a note. We don't even need to jump on the call. Don't be afraid. We wouldn't push you for a sales call or anything, but I'm happy to answer questions that you might have.
Perfect. Thank you so much.
I'd like to thank everyone for joining us from around the world. Again, we'll make the recording and slides available. And I'd also like to invite you to our next webinar. We will be talking about the OWASP Top 10 2022 predictions on February 24th. So look for that in the future. Thank you, everyone.
Thank you.